Okay. So last two classes, the first one is what is inference. What is the whole purpose of knowledge implementation? Right. What is the whole purpose of knowledge? The whole purpose of knowledge implementation is inference. To infer something. Suppose there is some information available in the website, okay, about VSSUT or any other institution. So that will be representing the knowledge about the institute. So then what inference you make by seeing the website, that is inference. Then the last part comes as resolution. Last part is resolution. Now we do it regularly. For example, many of you are club members. You might have seen. Any meeting, eventually we find a resolution of the meeting, right? Resolution. I mean, the points that are concluded. That is resolution. Now in the meeting, what happens is inference. Prior to the meeting, facts or knowledge. That means you will have all the notices. Right? You will have all the notices available with you. Say you are planning to purchase something for your club, okay, so you have all those codes, price codes, okay, so that is knowledge. In the meeting you infer something by discussing. Final is the resolution. So in KRR also the same concept applies. We have a set of knowledge known as conceptualization and based on the universe of discourse. We have a set of knowledge. And based on the knowledge, we infer something, and based on our inference, we create resolution. Okay, we create resolution. So, how to do resolution? We will do next class. Only one way of doing that. We will see resolution refutation. Today we will see how to infer. What is inference? What are the rules of inference? Okay, I will revisit it because we have already seen it. Refresh. You will come on and I will show up. Okay. The first one is modus ponens. Okay. It says, the premise is A implies B. A implies B. And B. Sorry. A implies B. A implies B given A. A implies B given A. That means we conclude B. That is modus ponens. It is raining, it will feel cold. Two sentences, A and B. Now suppose our knowledge base says AB, if it rains, it will be cold. So in that case, modus ponens, if applied, gives that given A implies B, or if it rains, it becomes cold. And I say it is raining, so I can conclude that it is cold. The next one is modus tollens. So here also the same thing. A implies B. Given not A, so we can conclude that not. Okay. This may not be valid. I am talking about rainy season. So if I go to winter season, this is not valid. Okay. So given if it is raining, it will be cold. Now it is not raining. So we conclude it is not cold, but that can happen only in rainy season, isn't it? Summer and winter. In winter it is not raining, but still it is cold. Okay. So it depends on our universe of discourse. Here our universe of discourse will be the rainy season. Then the next one is resolution. Resolution of a meeting, that we will cover in the next class. So resolution is A or B. A or B given not B or C. So in that case we conclude A or C. Okay, that is a logical rule. You think about it, you will appreciate it. But for now, remember this. Write down the rules. Okay. Not in detail, just the way I have written. How to make inferences in first order predicate logic. How to make inferences in first order predicate logic. An axiom, let's mention the keyword. An axiom is a well-formed formula that is asserted to be true without proof. So for axioms, we have domain-specific knowledge and input data. For example, I would say all of you belong to section A. Okay. So this specific information is relevant to VSSUT only, electrical. We have sections. Okay. So then is theorem is a well-formed formula. The theorem is a well-formed formula that can be proven true on the basis of axioms. Okay? There exists, how you read it. There exists X where X changes Nagesh. Okay. Some person. Something like experiment. So this is a theorem. It is generally, or Nagesh changes X. So X is, suppose X is money. Okay. So there exists something that we change. Right? So X can be Nagesh jagah Amanavi value. We chase happiness and prosperity. Right? We chase. So X can be happiness and prosperity. Right? Isn't it? We chase money, it's okay. But the eventual goal is happiness and prosperity. Okay, next. So that's a theorem. But that theorem is based on the axiom that we are human beings. Like if you give a dog some money in front of him, you won't like it. Okay, and if you give that to a cow, it will eat it. So axiom here is we are humans. Okay, humans love money. So that is the axiom. Bold. Last one is reasoning. Reasoning, the whole purpose of knowledge representation is reasoning, then making inference, and finally finding a resolution. Reasoning in logic-based AI systems is performed using methods of mathematical proof, that is sequence of inference rules. Next. So next is so how we make inferences in FOL? So I have told you. Last class I have found what is the difference between predicate logic or propositional logic and FOL is here we have quantifiers, which is for all. Okay. Now for every quantifier for all x dx we can give some constant. Okay. We can give some constant. So that is known as universal specialization. Okay. For A from here I thought it is. So swam for some x, for all x swam it's x. So the person swam it's x for all x, and that x we can give some constant. For example, ice cream. Okay. Then the other one is write down the keywords. The first one is universal specialization. The second one is existential instantiation. So this is known as collimation. What are you was collimation? I will ask you in the exam what is collimation. Okay, so note it. What is collimation? It's very simple. You put constants into variables. That is collimation. That is known as Colin constant. For example, we narrow the attendance into which keep fill up memory. Okay, Yash likes. So some Yash is there in your class, so he likes X. So here I have put Yash likes stuff, some stuff. That is known as existential instantiation, then existential generalization. Okay, there exists X, Px. For example, Ruchika eats ice cream. So there exists X which Ruchika eats. There is something. So she eats something. Okay, so that something is ice cream. So that is known as existential generalization. Then finally is universal generalization. So given a constant C, that means we see some instance. VSSUT electrical students are intelligent. Okay, first we will see. So suppose Harsi gave a good answer. So she is facing some interview. The interviewer asks questions and she answers all. But that is only specific to her. So C person X answers all questions. Okay. Now the employer generalizes it. BSSUT electrical students answer all questions. They are very good. And suppose one person is only after he or she gets selected is not performing very well, then they generalize. BSSUT students do not perform very well. Okay, so that is known as universal generalization. So from only one specific instant you generalize. Okay. Human beings are very prone to do this. Okay, with only one instant we tend to generalize. Okay. So universal generalization used when we show that for all x is true by taking an arbitrary element from the domain and showing that BC is true. Okay. But for human beings it is not true. You cannot take only one human being and generalize about all human beings. Okay, you can generalize something like they live, they breathe, they sleep, like that. You can generalize that, but not other things. Similarly, there are some domains. For example, an electronic component. There is a lot. So they do that. So they randomly check one, find the reliability, and they conclude that okay, the whole lot is reliable. That is known as universal generalization. Unification. So till now, first is we revisited the rules of inference, modus ponens, modus tollens, resolution. Okay, that we revised. The second slide we saw the rules, some rules, universal generalization, universal instantiation, and so on. Okay, and now we will see, and we knew a new term known as polemization. What is polemization? It is simply putting one constant to a general variable. Is the easy way of saying it, but you should write the definition by saying that. The next one is unification. How we unify? Unify means there are two statements, logic statements having variables. Now some constants connects those variables. Okay, that is known as unification. Okay, you can think of like you are from electrical branch, from mechanical branch there is another person. You are from electrical branch and you are working in that vehicle club. What is that? Supra. Beer racers, yes, beer racers. Okay. So in that case, that unifies your branches. So X can unify. You can choose someone from your branch and choose someone from their branch who is actually working there. So you are actually unifying both. So this is known as unification. So it is written in symbolic form here. So for all x, W1x implies W2x, not W1x or W2x. We write that in direction. Then W1A means, okay, we generalize that W1A. For universal specialization to produce W2A from 1 and 2, it is necessary to find out this A for X. That means, so if you can find out some person from electrical branch working on wheel racers, then you are likely to find another person from the mechanical branch which is working in wheel racers. Otherwise, that is not possible. That won't work. That is how it says. Okay. So it is a kind of substitutions. So these are called unifiers. So by unification, we can make a resolution. Unifiers used in a resolution proof provide handle for using the proof to answer questions. The terms of an expression can be variable symbols, constant symbols, or functional expressions. And I am adding to you. A substitution instance of an expression is obtained by substituting terms for variables in that expression. Okay. So unification means what? It is substitution. Okay. We are substituting some specific instance for variables across two domains, you can say. or two statements. So some examples are there to check it. How functions, like the function inside the okay. We write an expression E followed by a substitution S to denote the instance of the expression. Okay, you go through it. Okay, because going through it now won't serve any meaning. It is simply, as you see here, we are simply replacing variables with specification, special constants. Okay. Next point is most general unifier. So what is the most general unifier? What is the MGU? You write down the first statement. The most general unifier is the simplest substitution that satisfies the unification. Consider two terms, fxy and faz. We can unify these terms by the substitution. If we replace x by a and y by z, then we say that this is the most general unifier. Here a and z may constitute two characteristics or two persons that most faithfully represent VSSUT. So in that case, this fxy can represent all students of VSSUT. It's kind of that. Okay. Minimum. Okay. Simplest substitution. We can unify these terms by substitution x by a, y by z. Okay. Thus applying theta to both terms, this fxy simply becomes faz. Okay. The general instant becomes the specific instant. So till now, things might be a little hazy. So we'll see why it is important. Okay. So that will clarify what is unification. Why it is important. Now, unification matters because it represents human-like intelligence or it enables human-like intelligence. Human intelligence is not domain specific, right? Are we? We are not domain specific. By separating our knowledge base into separate disciplines like electrical, mechanical, civil, etc., or engineering, humanities, we are actually doing a disservice to humanity. We are not domain specific. Okay, we can work, okay, but knowledge is not domain specific. If you are an electrical engineer, you are very likely to do something else which you have not studied in these 4 years. Okay. So therefore, what unifier does? It unifies what you have read as a general study with the specific thing that you do at a level. Right? So that unification is made when you transition from study to a professional career. So human intelligence is not domain specific. We seamlessly switch between conversation. We seamlessly, without any break, we seamlessly switch between conversation, visual understanding, and logical thinking. Okay, a unified AI system would better mimic this fluidity. So you can design an AI system which can do unification like this. Enhanced collaboration, unified frameworks promote interdisciplinary research by integrating insights from various fields like all these fields, okay, leading to breakthroughs. So unification leads to breakthroughs, not a single one shallow study of any single branch. You cannot do great things by studying electrical engineering, focusing on electrical engineering only. You need to get ideas from other domains as well. That's why AI is so powerful. Okay, AI can be considered as a unification of all disciplines. Okay, scalability. So when you unify things, you actually make systems scalable. Unified AI systems are more scalable than they can generalize to new tasks and domains without requiring extensive retraining. Okay, if you are actually making a system which is general, more general, like human, no? Right? Clause. Okay. So this topic we will discuss in the next class because conversion to clauses and clausal form is something that will be asked in the exam and that is required for resolution. Till now, जोड़ा पढ़ लो theory. But now onwards, what we are going to do is some problem will be given to you that you have to divide into clauses. Okay. So what is a clause? What is a clause? A clause is defined as a well-formed formula consisting disjunction of letters. Write down. Write it down.